Okay, let's talk about rate of change, otherwise known as slope. Alright, now, when we talk about slope, the one letter that we always refer to is the letter M, okay? Whenever you see the letter M in the equation, y equals mx plus b, the m is your slope, not the x. The x is a variable, so you have x and y. That is any coordinate point on a line, okay? Now, the m, again, that's your rate of change, that's your slope, that's your rise over your run. The b, in this case, is your y-intercept. That's where it's going to cross the y-axis. So let's look at some various ways to refer to slope. Most of you refer to it as rise over run. Now, when we do a rise over run, we also look at this. So your rise can either go up or down, and your run can go left or right. All right, so those two kind of pair up. Then, another way we talk about it is delta y over delta x. Remember, delta means change, so it's change in y over your change in x. Now, when we use the word change, we refer to subtraction. So now let's go to this. In order to find your slope, when you're given a coordinate point, you simply subtract y minus y and the corresponding x minus x. So it doesn't matter if you go this way or if you go this way, as long as you do it the same direction on both. For instance, let's take a look at some problems. Now, on this first problem, we have a graph. Now, we could do rise over run from one point to the next. So I'm going to go from this point here to this point. And I'm going to go 1, 2, and you count the blocks. I went up 2 units. And then 1, 2, 3, I went to the right 3 units. So again, my slope would be rise over run. So I rose up positive 2, and I went to the right 3. So my slope is 2/3. Now notice I've used these points down here. And I'm going to utilize the m equals y minus y over x minus x. So in this case, I'm going to choose this y first. So negative 3 minus negative 1. So negative 3 minus a negative 1. I'm also going to go in the same direction and choose 1 minus 4. 1 minus 4. Notice I used the 3 first and I used the 1 first. So now this gives me negative 3 minus a negative 1 is plus plus, so that gives me negative 2. Now, 1 minus 4 is negative 3. But you have a negative over a negative, so that is actually a positive. And if you notice, it's the same slope as the one we used doing rise over run. Alright, so let's take a look at this at one of these other two problems. Let me move this out of the way. Okay. Now, let's take a look at this problem. Number 2. Same thing. Now, I'm going to choose the graph. I'm going to go down all the way to here and then to the right. So notice I went down on this part. So that is, I went from negative 3 down to negative 5. That is a drop of 8. So I went down 8 units. And then I went to the right. You can count it. 1, 2, 3, 4, 5. So I went to the right 5 units. So my rise in this case is I went down 8 and I went to my run is 5. If you take those two coordinate points, it's negative 2, 3. Oh, that's not a very good number. Alright, so negative 2, comma 3. And the other coordinate point is 3, comma, negative 5. Alright, so if I do, let's go this way. Negative 5 minus 3. So negative 5 minus 3 over, and we got to go 3 minus a negative 2. So 3 minus a negative 2. Well, what you end up getting is the top portion is negative 8, and 3 minus a negative 2 is actually plus plus, So that is 5. And notice I got the same slope as I did with the graph. And that's basically how you kind of coordinate or determine what the slope of the line is. Either with coordinate points, doing y minus y over x minus x, or simply just counting the placement of rise over run. Now, in this particular case, tell whether the slope of the line is either positive, negative, or undefined. Now, remember we read from left to right. So as I move along this way, notice as my x's, what's happening to the y values? Well, my y values are increasing. Okay? Even here, as I'm moving this way, my y values are increasing as I move to the right. So this is a positive slope. Now let's take a look at these next two problems. Okay, these next two problems are interesting because one is horizontal, that's this one, and one is vertical. Okay, now let's pick some coordinate points. So let's pick this one and this one. So let's say that could be like -3, -1. And this one could be +2, -1. Now if I do slope on this one, let's do -1 minus a -1. Okay, -1 minus a -1 over, and let's do -3 minus 2. So -3 minus 2. Well, what you end up getting is plus plus, so I get -1 plus 1, which is 0, over -5. Now, let's take a look at this one. That looks like it's about at -2. So let's do -2, 0, which is that point right there on the line, and let's try the one above, so it would be at -2, let's say 3. Well, if I do the slope, I end up getting 0 minus 3, 0 minus 3, so I'm going to choose that direction, and then -2 minus a -2. So I end up getting -3 over 0. Well, one of them has to be undefined and one of them has to be 0. So let's take a look at this. I'm going to move these up for a second. Now watch. With that being said, I'm going to do -5 divided into 0. And then here, I'm going to put 0 divided into -3. Well, think about this. Is there anything that I can multiply -5 by to get 0? Well, yeah, the answer is 0. So 0 times -5 is 0. Subtracting, you get 0. So this is a slope of 0. So this one, if you have a horizontal line, it will always have a slope of 0. All right, and let's take a look at this last one. Is there any number that I can multiply by 0 to get -3? And the answer is no. So this one is undefined. So anytime you have a vertical line, we're simply going to say this is undefined. Okay, the instructions on this says graph the data and show the rates of change. Okay, well, let's just go ahead and graph this data and see if we can come up with an answer for that. 0, 0 is going to be right here. 2, let's see, gas used and miles driven, so 260 is going to be about right there. Let's make that a little darker. And then 5, 150 is going to be about right there. And then 6, 170. All right, it's going to, since it's increments of 10, 6, 170 is going to be about right there. And then 9, 230 is going to be about right here. And then finally 11, 260 is going to be way out here. So 40, 50, 60, so it's going to be about right there, I believe. Okay, so now what it wants us to do is, it shows the distance a car drove on 1 tank of gasoline. So from right here to here. it wants to know our rate of change. So our rise was 60 and our run was 2. Okay, so that gives me 30 over 1. And that was from 0, 0, so a run of 60, and then over 1. So what I'm going to do is I'm going to take this chart and actually, let's do this. I'm going to redo that chart. So 0, 60, 150, 170, 230, and 260. Alright? And then I have 0, 2, 5, 6, 9, and 11. So between 0 and 60, so that's 60. This is an increase of 2. So 60 divided by 2 is 30 over 1. Now to go from 60 to 50, that's an increase of 90. And to go from 2 to 5, that's an increase of 3. So I have 90 over 3, which is 30 over 1. So I have 60 over 2, 90 over 3. Now, let's do this next one. 150 to 170 is an increase of 20 over 1. Alright, so we have 20 over 1. 170 to 230 is an increase of 60 over 3. So 60 over 3 is actually 20 over 1. And then finally, 230 to 260 is an increase of 30 over 2. And that is, when you get 30 over 2, that actually reduces down to 15 over 1. And the question is, between which two measurements was the gas mileage the least? Well, it would be this one, the very last segment. So it was 15 miles for 1 gallon of gas. So you have to find each individual ratio in order to compare them all.